The problem statement from GATE Physics 2018 reads as follows. An N-channel FET having gate source switch off voltage VG off equal to minus 2 volts is used to invert a 0 to 5 volts square wave signal as shown. So you can see the input over here, this is square pulse, and the output is just an inverted signal for this. So this is the JFET that the question is talking about. Now the question asks the maximum allowed voltage value of R would be. So this is the resistor we are talking about over here. The maximum allowed value of R would be dash kilo ohms. So we need to find the value of this resistor R in kilo ohms, and since this is a numerical answer type question, we'll round it off 2 decimal places and fill in the blank over here. Note the units is kilo ohms. And this is the question that is given to us. Note that what this question is doing, it's inverting this, so it's low. When the input is low, the output is high, and vice versa. When the input is high, the output is low. This JFET is operating in this ohmic region. So this is where it's operated in order to, this is just an inverter function. So it's the JFET is operating in this region. So it goes from pinch off to saturation. So it's operating somewhere in this blue regime that we see over here, and it's behaving as a switch. So sometimes it's also known as switch or inverter. It's the same thing that we are talking about, and this is the reason that we are interested in over here. Right, so this was the problem. VGS of is minus 2 volts, and this is this. I have just reproduced the diagram over here, and let's just first case about the case 1 when V in is 0 volts. Note that when the input is low and the output is high, and we'll try to figure out the value of R over here, right? And let's just put in all the currents over here. So as always, we assume that Ig equal to 0. We assume that no gate current is there. So if no gate current is there, so we can simply say that Id equal to Is, right? So that's a very fair assumption, because so let me do this. Step 1 is KCL across NJFET. So I can write Ig plus Id, that's the inflowing current. It should be equal to outflowing current. Since Ig is 0, this will give me Id equal to Is. So the drain current is nothing but the source current. Right, let's also now label some nodes. So this is the drain, this is the source, and this is the gate. I've just labeled it for easier understanding. Now what we'll try to do is that now we'll first try to figure out that whether this JFET is conducting is working or not, or it's pinched off. So how to do this? So that's step 2. So what we'll do here is that I'll try to find out the ID, because I know the output voltage here. So what I do is, step 2 is I'll apply Ohm's law across RD. So I'm calling this resistor as RD. Okay, so let's do that. So that will be 5 minus VD is equal to ID times 5K. So ID from here will come out to be 5 minus VD is 0. Note, VD is nothing but V out over here, and this is 5. So this will be 5 minus 5 over 5K. So ID is coming out to be 0 milliamps. So what this means is that this device is pinched off, and we saw that over here. So this means this device is operating somewhere in this region, right? And we know, so we'll write this is pinched off, right? So what does the pinch off condition mean? So that's a step 3. So pinch off condition means that VGS is less than VGS off, right? So this implies VGS is less than minus 2 volts. So we have obtained this condition. Now we just need to find what's the value of VGS, and note that VS will be equal to 0. So since ID is 0, note that ID is 0, so IS will also come out to be 0, and so no voltage will drop across this resistor. So VS will also come out to be 0 volts, right? So we just need to find out the value of VG over here, and that we can do very easily, since this is nothing but a potential divider over here. So I can directly write the expression, but let's derive it. So what I'll do is I'll apply Ohm's law across. So I'll equate the current through this as well as this. So let's do that. So the current will be flowing in this direction. So I'll write 0 minus Vg over R. That's the current flowing through this resistor, and all the current will flow here because Ig is 0, no current is flowing here. So this will be equal to Vg minus minus 12 over 1k, right? So this is the expression that we have obtained, and let's just try to solve it. So this will be minus Vg over R. So I'll assume R is in kilo ohm, so I'll drop this k over here. So this will be Vg plus 12. So so this will give me that Vg. So Vg, if I take towards that side, it will be minus 12R over 1 plus R. Now we know that Vg should be less than minus 2 volts, right? Vgs should be less than minus 2 volts. We have obtained that. This means Vg minus Vs, which is equal to minus 12R over 1 plus R, should be less than minus 2, right? So if we try to solve this, this will be 6R greater than 1 plus R, and this will give me R should be greater than equal to 0.2 kilo ohms. So this is the first condition that we have obtained, that R should be greater than 0.2 kilo ohms. Now let's consider the second case when V in is high, that's 5 volts, and V out is 0, and again we'll try to find out the value R. And so these are the current flowings over here. Ig is 0, assume that no current is flowing, and so consequently Id will be equal to Is. We just saw that, so I'm writing it again, Id equal to Is. We know this information. And also let's label the nodes here. Now again I'll try to find the current that is Id over here, right? So I'll write, so this is the step 1, Id equal to Is. We saw KCL in JFET gave us Id equal to Is. So step 2 is Ohm's law across Rd, that is the 5 kilo ohm resistor. This is what I'm calling Rd, this resistor. Right, so let's do that. So it will be 5 minus V out. This should be equal to Id times 5k, and this will give me Id equal to 5 minus 0 over 5k, which is nothing but 1 milliamps. Now this is important. Now we do notice that some finite current, non-zero current is flowing through this FET. This means this FET is not in pinched off condition. So we see that this means this FET is somewhere operating in this blue regime, right? So it's not in pinch off condition. So this means I can write FET is not pinched off. This is important, not pinched off. This means VGS is greater than equal to minus 2 volts, because this is the VGS off condition. This was given to us, right? So now we will just simply find out what is the value of Vg. Vs is again will be very small, so we can ignore Vs and we'll assume it to be 0. Note that since all the voltage is being dropped across here, so we'll simply assume that nothing. So this is again grounded. Note that this is grounded, right? So if this is grounded and this is minus 12 volts, so if this is grounded, then there's the very small potential drop we can assume. We are operating, you can assume, very near to this vertical edge, somewhere over here. The VGS is minus 2 volts, so, and this implies since Vs is 0, Vg should be greater than minus 2 volts. So this is the condition that we have over here. Now step 3, what we'll do is Ohm's law across R and 1k. So note that since no current is flowing here, the current flowing in this resistor should be equal to the current flowing in this resistor. So I'll write that. That will be 5 minus Vg over R. This should be equal to Vg minus 12 over 1k. So again I'll assume that since in the units of kilo ohms, so I'll drop this k over here. So this will be 5 minus Vg over R equal to Vg plus 12, and if I rearrange some terms here, then I'll get Vg. The Vg I can write as, Vg can be written as 5 minus 12R over 1 plus R. This is the value of Vg, and we know that this 5 minus 12R over 1 plus R should be greater than should be greater than minus 2 volts. So if I try to solve it, this I'll get 5 minus 12R should be greater than minus 2 minus 2R. So this will give me 10R should be less than 7. This implies R should be less than 0.7 kilo ohms. So we have obtained that R should be less than 0.7 kilo ohms, and in the previous slide we saw that R should be greater than 0.2 kilo ohms. So this means the value of R should be greater than 0.2 kilo ohms and should be less than 0.7 kilo ohms. You can also put an equality here because we are operating at the near boundary, so for analysis it won't matter much. The question had asked the maximum allowed value of R. So maximum allowed value of R is 0.7 kilo ohms. So I'll write here 0.7. So 2 decimal places I'll write it as 0.70 to make 2 decimal places, and that is the answer that we were required to obtain. Note, it's you can again put inequality choice. See note that we had here inequality over here. So you might as well do it greater than equal to minus 2 because we are operating near the boundary condition. So hence I put this equality also over here. So the answer is 0.7 kilo ohms. Thank you for listening.